Most people look at a fire extinguisher and see nothing more than a red cylinder hanging on a wall. You pull the pin, aim at the fire, squeeze the handle, and hope for the best. But not every extinguisher is built for every fire, and using the wrong one can actually make a fire much worse than it already was. Some extinguishers were designed for burning paper, others are for gasoline and flammable liquids. Some can safely put out a fire in energized electrical equipment, and there are even extinguishers built specifically for burning metals or cooking oil. So today we're breaking down every major type of fire extinguisher, how each one actually works, and when it should and should never be used. Before we look at the extinguishers themselves, there's one fundamental concept that needs to be clear. Fires are divided into classes based on the material that's burning. This isn't just bureaucracy. It's what determines physically which substance will put out the fire and which one will feed it even further. Class A fires involve ordinary combustible materials like wood, paper, cardboard, cloth, and many types of plastic. These are the classic fires, the ones most people picture when they think of flames. Class B fires involve flammable liquids such as gasoline, diesel, oil, paint, alcohol, and solvents. Here the danger changes in nature. It's no longer a solid material burning slowly. It's flammable vapors that can spread and reignite with ease. Class C fires involve energized electrical equipment. The presence of live electricity completely changes the rules of the game because now there's a risk of electric shock, not just burns. Class D fires involve combustible metals like magnesium, titanium, sodium, and lithium. These are some of the most treacherous and least understood fires by the general public because burning metals react violently with substances that would normally put out any ordinary fire. And Class K fires involve cooking oils and animal fats typically found in commercial and industrial kitchens. Each of these classes requires a different method of firefighting: cooling, smothering, interrupting the chemical reaction, or isolating the material. That's exactly why so many different types of extinguishers exist. Let's start with the most common one. The water extinguisher is designed specifically for Class A fires. It works in a simple, direct way. The water absorbs the heat of the flame and cools the burning material below its ignition temperature. Without enough heat, the chain reaction of combustion simply stops. It's extremely effective on wood, paper, cardboard, and fabric. Exactly the materials most common in homes, offices, and storage spaces. But here's the critical point: it should never be used on flammable liquid fires. Water, being denser than most of these liquids, can actually spread the burning fuel across a much larger area, turning a small fire into an uncontrolled one. It should also never be used on energized electrical equipment because water conducts electricity and dramatically increases the risk of shock for whoever is holding the extinguisher. Simple, effective, but only when used on the right type of fire. The foam extinguisher is commonly used on both Class A and Class B fires. It releases a layer of foam that spreads across the burning liquid. This layer does two things at once. It separates the fuel from the oxygen in the air, and at the same time provides a cooling effect on the surface. Because the fuel stays sealed beneath this layer, the chance of reignition, the fire coming back after appearing to be out, that is much lower than with other methods. That's why foam extinguishers are common in warehouses, garages, fuel stations, and industrial storage areas, where large volumes of flammable liquids are often present. Think of it as a protective blanket laid over the fire until it runs out of oxygen to keep burning. One of the most visually recognizable extinguishers is the carbon dioxide extinguisher, or CO2. Instead of water or foam, it releases compressed carbon dioxide gas under high pressure. As it leaves the nozzle, the gas expands rapidly, displacing the oxygen around the flames while also producing a strong cooling effect. CO2 is especially effective on Class B fires involving flammable liquids and Class C fires involving energized electrical equipment, since the gas doesn't conduct electricity. Because carbon dioxide leaves no residue at all after use, these extinguishers are the natural choice for offices, server rooms, laboratories, hospitals, and any environment full of expensive, sensitive electronics. The fire disappears, and most of the time, the cleanup afterward barely even exists. Dry chemical extinguishers are the most common ones found in homes, schools, offices, hotels, and public buildings in general. Very likely the model you've seen the most times in your life. Inside the cylinder is a fine chemical powder. whose job isn't to cool the fire, but to interrupt the chemical reaction that keeps combustion going. The most popular version is the ABC Dry Chemical Extinguisher, which can handle Class A, Class B, and Class C fires all at once. It's exactly that versatility that turned it into one of the most widely sold and used extinguishers in the world. The downside is that the powder leaves a messy residue, which can damage electronic components if it isn't cleaned up carefully right after use. It might save your building, but your computer probably won't be too happy about the result. Dry powder extinguishers look visually similar to dry chemical models, but they serve a very different, much more specific purpose. They're designed exclusively for Class D fires involving combustible metals, burning magnesium, titanium, sodium, potassium, and certain lithium-based materials require special powders that absorb heat and physically isolate the burning metal, forming a crust that cuts off contact with the air. Water can react violently with some burning metals, causing explosions and releasing flammable hydrogen gas. Even carbon dioxide, so effective in other situations, can become ineffective, and in some cases dangerous, against certain burning metals. When metal catches fire, the normal rules of firefighting stop applying. Wet chemical extinguishers are designed almost exclusively for commercial kitchens. They're used on Class K fires, involving cooking oils and animal fats at high temperatures. Instead of simply cooling the flame, the wet chemical agent reacts with the hot oil in a process called saponification. Essentially, the reaction that turns fat into soap. This process creates a thick, soap-like foam layer that seals the surface of the oil and prevents the fire from reigniting. Restaurants, industrial cafeterias, and commercial kitchens rely heavily on this type of extinguisher because throwing water onto burning cooking oil causes a violent explosion of burning grease, spreading the fire across the entire kitchen in a matter of seconds. The wet chemical extinguisher solves the problem without launching fire through the air. Clean agent extinguishers have become increasingly common in environments that house sensitive, high-value equipment. Instead of powder, they release special gases that leave virtually no residue after use. These extinguishers are typically found in museums, data centers, laboratories, aircraft, telecommunications facilities, and archive rooms storing historical documents. They put out fires by interrupting the combustion reaction or reducing the heat of the flame without damaging what's around them. Sometimes protecting what surrounds the fire is just as important as putting out the fire itself. Automatic fire extinguishers work in a completely different way from the handheld models we hold in our hands. Instead of waiting for a person to notice the fire and react, they activate automatically when exposed to high temperatures. Some are installed inside electrical panels and cabinets. Others protect engine compartments, server racks, boats, industrial machines, or exhaust systems in commercial kitchens. The moment a preset temperature is reached, the extinguishing agent is released without any human intervention. Sometimes, the fastest firefighter is the machine already waiting silently above the danger. So, in practice, how do you know which extinguisher to choose in an emergency? Most modern extinguishers display symbols and letters indicating exactly which fire classes they were designed for. Before acting, always identify the type of fire in front of you. Never assume that every red cylinder does the same job. Using water on burning oil can spread the fire. Using water on live electrical equipment can cause a serious shock. Using the wrong extinguisher on a burning metal can actually intensify the fire instead of putting it out. Knowing which extinguisher to use can be the difference between containing a small fire and creating a much bigger emergency. Fortunately, operating most handheld extinguishers follows the same basic procedure, summed up in an easy-to-remember acronym for any stressful situation: PASS. Pull the safety pin. Aim at the base of the fire, not at the flames higher up, but at the source. Squeeze the handle. Sweep the nozzle from side to side, covering the whole area that's burning, and the entire time, keep a safe exit behind you. If the fire keeps growing, or if smoke fills the area, leave immediately and call the fire department. A fire extinguisher is designed to fight fire in its earliest stages, a small fire just starting out. It doesn't replace professional firefighters. From water to foam, through carbon dioxide, chemical powders, clean agents, and special powders for metals, every type of fire extinguisher exists for one single purpose: to put out fire as quickly and safely as possible. The challenge is that not every fire behaves the same way. Understanding the differences between extinguisher types can, one day, protect your home, your workplace, and your equipment. or even save a life. So the next time you walk past an extinguisher hanging on a wall, remember, that red cylinder isn't just some piece of emergency equipment. It's a tool carefully engineered for one very specific mission, and now you know every major type of fire extinguisher that exists.